According to multiple reports, China recently successfully conducted a non-nuclear hydrogen bomb explosion test. This technological breakthrough has attracted widespread attention in the military and energy fields. The following is an analysis of the test process, technical characteristics, significance of conventional military strength enhancement, and significance of the development of detonation flight engines. Test process 1. Time and location. The test was completed at a test site in the northwest around April 20, 2025, led by the 705th Institute of China Shipbuilding Industry Corporation. 2. Core device. The test device is 2 kilograms of magnesium hydride, MgH2, which triggers a thermal decomposition reaction through conventional explosives. Releases a large amount of hydrogen and mixes with air to burn, forming a high-temperature fireball. 3. Energy release. The explosion produces a fireball of more than 1000 degrees Celsius, lasts for 2 seconds. And the thermal effect coverage is 15 times that of TNT explosives of the same mass. 4. Trigger mechanism. Using the original thermal decomposition trigger technology, 90% of the stored hydrogen is released within 0.03 seconds, and the burning speed is 30 times faster than traditional chemical explosives. 2. Technical features. 1. Material breakthrough. Magnesium hydride hydrogen storage density, 150 grams per liter, which is 3.75 times that of traditional high-pressure gas tanks, significantly improving energy density. Solid-state storage, stored in powder form, small size, high safety, easy to integrate into weapon systems. 2. Energy release mechanism. 3-stage release. Explosion shock wave, peak pressure 2.5 megapascals within 0.5 seconds, continuous combustion, fireball temperature 1000 to 1200 degrees Celsius. Residual temperature effect. Magnesium oxide aerosol maintains local high temperature for 30 seconds, achieving slow cooking damage. 3. Environmental protection and controllability. The explosion products are only water and magnesium oxide, without nuclear pollution or radioactive residues. Adjustable equivalent. From 0.5 kilograms, precise strike on a single tank, to multiple salvos, covering a 3 square kilometer high-temperature restricted area, flexible to meet tactical needs. 4. Military-civilian integration potential. Yulin, Shaanxi has built the world's first magnesium hydride mass production line. With an annual production capacity of 150 tons and a cost as low as 80,000 yuan per ton, far lower than similar technologies in the United States. 3. Significance to China's conventional military strength enhancement. 1. Improvement of tactical strike capability, anti-ship missiles. The Eagle Strike 18 missile equipped with a magnesium hydride warhead has an explosion fireball diameter expanded from 30 meters to 80 meters, which can burn through 3 decks of an aircraft carrier. Drone clusters. The J-36 stealth fighter can carry 24 miniature magnesium hydride bombs, 5 kg each. And a cluster of 100 drones can cover Taipei Songshan Airport. Anti-fortification operations. High-temperature flames penetrate 3 meters thick concrete and destroy underground bunkers, which is suitable for urban street fighting. 2. Strategic deterrence advantage. Sub-nuclear deterrence. The power is close to that of tactical nuclear weapons, such as 30 kilograms of explosives equivalent to 450 kilograms of TNT. But it circumvents the restrictions of the Nuclear Non-Proliferation Treaty and can be legally exported. Regional denial capability. Threaten the U.S. aircraft carrier formation and force the adjustment of the rules of the battlefield in the Western Pacific. 3. Energy and military synergy. Magnesium hydride technology extends to the civilian field. Sub-nuclear deterrence. The power is close to that of tactical nuclear weapons, such as 30 kilograms of explosives equivalent to 450 kilograms of TNT. But it circumvents the restrictions of the Nuclear Non-Proliferation Treaty and can be legally exported. Regional denial capability. Threatens the U.S. aircraft carrier fleet and forces the adjustment of the rules of the battlefield in the Western Pacific. 3. Energy and military synergy. Magnesium hydride technology extends to the civilian field, such as energy storage systems, Qinghai Terra Beach 2 gigawatt-hours energy storage project, and fuel cells, endurance of 1,200 kilometers, forming a military-to-civilian industrial chain. IV. Significance to the development of detonation flight engines. 1. Fuel supply optimization. The high hydrogen storage density and rapid hydrogen release characteristics of magnesium hydride can provide an efficient fuel source for detonation engines and solve the problem of traditional hydrogen fuel storage. 2. Improved combustion efficiency. Detonation engines rely on explosive combustion, such as rotating detonation. While the rapid thermal decomposition mechanism of magnesium hydride can enhance the mixing efficiency of fuel and air and stabilize the propagation of detonation waves. 3. Technology synergy application. China has verified the flight capability of Mach 9, using aviation kerosene, in the oblique detonation engine experiment. In the future, combined with magnesium hydride technology, it may break through higher speeds, such as the theoretical limit of Mach 16. 4. Military equipment upgrade, if the detonation engine is combined with magnesium hydride fuel. Hypersonic missiles, such as upgrading a torpedo with a range of 120 km to 300 km, or the power system of the 7th-generation aircraft can be developed to enhance the penetration and strike capabilities. Summary: China's non-nuclear hydrogen bomb test marks a revolutionary breakthrough in conventional weapons technology, the core of which lies in the application of magnesium hydride materials and the innovation of energy release mechanism. This technology not only enhances China's asymmetric advantage in regional conflicts, but also promotes the development of clean energy and high-end manufacturing through military-civilian integration. At the same time, the potential of magnesium hydride in the field of detonation engines may provide key technical support for the research and development of future hypersonic weapons and aerospace vehicles, further consolidating China's leading position in the field of cutting-edge military science and technology.